All right, everybody. So today we are going to start our lesson on proofs with similarity. So proofs with similarity. The three ways we've kind of looked at in the past to show or to prove that triangles are similar are these three. So we had the angle, we had the side, and we had the side relationship. So this is a video we looked at, in the main part of this packet, main part of our unit on similarity. These were the three main ways we looked at showing that triangles were similar. For the proofs that we're doing today, and almost all the time with these actual proofs, this is going to be our method. Because if you recall from earlier in the year when we started our proofs with triangles don't usually have numbers applied to them. They don't have official, like, specific angle measures, and they don't have specific side lengths. So if we don't know the actual lengths of the sides, we can't use these two methods because we can't test our proportions. So usually with these triangle proofs, our main approach is to look for this angle-angle relationship. Okay, so a couple of these we're looking at now are proofs that we've been very familiar with. We've looked at very similar proofs, no pun intended, but very similar proofs in our notes, like our main note packet for this similarity stuff. So if you want to try a couple of these on your own and see how you do, you can definitely do that. Pause my video, try them out, and then you can unpause and watch me walk you through them. So I encourage you to try them on your own if you feel like you're ready. But I understand if we want to kind of like get familiar with our proof rules again. So this was actually a very like problem that we've done a bunch of times this unit. So what we know is that we have a couple lines that intersect, and we know that AB is parallel to CD. A really common mistake I've seen a lot of people doing lately is when they see these parallel lines, a lot of people have told me, oh, since the lines are parallel, it means these two lines are also equal. All right, but looking at the picture, that's obviously not true. Parallel lines are not necessarily congruent. That's a very different thing. Parallel lines, when it says they're parallel, all it means is that they're parallel. It doesn't mean that they're congruent. It doesn't mean that they're equal. It only means that they're parallel. So looking at this question, it is asking me to prove that these triangles are similar. So it looks to me like we have another one of those situations where we have a rotation that will map one triangle onto the other, as well as our dilation. So I need to match up two angles of one triangle with two angles of another triangle. So first thing we'll do is we'll get our givens in. And I'm just going to go like that, and you can pause and write them at your own pace. But I'm going to just keep moving to keep this video short. Hopefully what we are all seeing now that is automatic at this point is our vertical angles. So that's one of my two pairs. All right, so go ahead and pause and write that down if you need to. Please make sure you are comfortable writing the names of the angles down. So if I tell you to look at angle AEB, you need to know where angle AEB is. And if you don't know that, if you're not comfortable with it, we have to fix that. So we have our vertical angles. The other thing that we've spent a lot of time this year looking at now is our parallel lines. So if I have parallel lines, really anytime in a proof that you see parallel lines, or if you're trying to even prove parallel lines, we'll get to that more later on, we always want to look at those angle relationships that we know. So alternate interior, alternate exterior, or corresponding. So in this particular problem, I actually have a few different angles that I can mark up in this picture. I think I like the looks of angle A and angle D. And I know those are congruent because if the lines are parallel, then the alternate interior angles are congruent. I could have also done angle B and angle C. Okay, but all you need are two angles to prove similarity. So at that point, we're done. We no longer need to find three things to prove. All we need are two. Okay, so that's our main idea for these angle-angle similarity proofs. So get out that old note packet we had that has all your proof rules in there. We're going to need a lot of them. We'll definitely need parallel lines. We're definitely going to look at a lot of perpendicular lines. So remember that symbol, that upside down T, means perpendicular, which we know makes right angles. And then this is that weird kind of like two-step thing we've talked a lot about. So we know we have perpendicular lines. It means that they're right angles. And if we have right angles, the next thing we would say in our proofs are that all right angles are congruent. So you might want to make a little note of that because we'll definitely be needing that over the next couple days. Okay, so let's move on to number 3. Again, if you want to try it on your own, please feel free. I'm going to do this proof as a paragraph proof, or like make it and do some bullet points. So if you don't want to do the statement, reason, column thing, if you don't like that, you can try it this way. Okay, EBD is this triangle right here. So EBD, it looks like we have an overlapping triangle situation. So I'm going to take EBD. I'm going to make it down there. So you guys can redraw your triangles just like always. That is one of our major strategies for this unit. That wasn't perfect, but we'll go with it. We also have triangle ABC. So I'm going to take my blue triangle ABC and I'm going to move it down here. So another really common thing you're going to see this unit, let's see what I did first. Yeah, so I wrote my givens down. So make sure you're writing your givens down like always. And you can see again, I just did it with a bullet point instead of with our column. Another thing you're going to see a lot this unit are shared angles. All right, shared angles. Another way we've talked about that, we've called it the reflexive property. When something is the same exact thing, it could be a side, it could be an angle, in two triangles. So if you look at this picture, if I look up at angle B, and this is sometimes what helps me to put a number to it, let's say angle B is a 30-degree angle. It kind of looks like 30. That means it's a 30-degree angle in this triangle. It means it's a 30-degree angle in that triangle. So that's a huge piece of information. I can say angle B is congruent to angle B because it is a shared angle. Another way to say that is the reflexive property. Okay. Next, we have those parallel lines. They are not going to put something in your proof unless you use it. I didn't say that right. They're not going to give you a piece of information in your proof unless they expect you to use it, unless you have to use it. So that symbol, I know it looks funny. I think it is. I just probably forgot to italicize it. There's another way that parallel will look. But in this case, I have a really helpful relationship. I know ED is parallel to AC. Again, that doesn't mean that the angles are similar. Man, I'm all over the place today. It doesn't mean that the lines are equal to each other. It doesn't mean those lines are congruent. All it means is that they're parallel. So if I look at my parallel lines cut by a transversal, I can go back to my alternate interior. I can go back to my alternate exterior. In this case, we have a set of corresponding angles. So it's probably a little easier to see now that I put those red lines in. Okay, but that's the next piece that we can discuss in our proof. And I could have picked the other ones. I could have picked the angles over here. I just happened to pick the ones on the left. But I know that angle BED is congruent to angle BAC because corresponding angles are congruent if lines are parallel. Okay, so the parallel lines are going to be coming up a lot this unit. And there you go. We're done. We have our two pairs of congruent angles. That tells me the two triangles are similar because of angle-angle similarity. And notice I'm labeling these very carefully. I'm making sure the corresponding parts are matched up. So E matches to A, B matches to B, D matches to C. So I'm labeling them, I'm naming them very carefully. So a lot of people find these similarity proofs easier because all you really have to look at are the angles. If you start looking at segments, like if I say BD and BE are congruent, it means you're probably on the wrong track. All we need to do is find angles for these proofs. Okay, so let's do one more. Again, if you want to try it on your own, you can. I'm going to mark my givens in first. And actually, this is interesting. We have something new in this problem. We have an actual set of angles they told us about. So in this given, they told us angle 1 is congruent to angle A. All right, angle 1 is congruent to angle A. So that makes me think for a second. Why the heck did they tell us about angle 1? Angle 1's not in our triangle, but they gave us some information about it. So that's setting off some red flags in my head. So how can I tie in angle 1 into this puzzle? It looks to me, let's see. All right, I know angle 1 connects to angle 2 because they're vertical angles. So that at least gives me a little bit of forward progress. I'm working with an angle that's in my triangles now. And I guess I kind of glossed over that. Let's make sure we know what we're trying to do. I'm trying to prove this triangle here, my yellow one here, is similar to the green one here. So by using angle 2, now I'm getting somewhere. So I'm going to say angle 1 is congruent to angle 2 because vertical angles are congruent. That's a rule that works no matter what. So hopefully you notice something interesting here. If I look at statement 1 and statement 2, look at this. You guys see how angle 1 shows up in both of those problems? That's really meaningful. So if I know angle 1 is congruent to angle A, and I also know angle 1 is congruent to angle 2, I can basically cut out the middleman. The example that I always talk about in class is like if angle 1 owes angle A $1, let me say it again. If angle A owes angle 1 $1, and if angle 1 owes angle 2 $1, we can kind of cut out angle 1 and just give that dollar to angle 2 right away. All right, so that's kind of the two ways I think about this. Really what I look for is if a proof has two different things like this, two different steps where the same thing shows up. So if angle 1 shows up and is congruent to two different things, I know that those two different things have to be congruent to each other. So the way we call this, the way we named this was the substitution property. So if angle 1, and you could even write this. I've had people in the past write it out like this. So I'll just jot it down here. You don't have to write this all out. But I've had people say this. If angle 1 is congruent to angle A, and angle 1 is also congruent to angle 2, then angle A must be congruent to angle 2. All right? It's a lot longer, but if let's say you just forget what the substitution property was, if you just forget what to call it, you can always just lay your thoughts out logically like that. So that could go here if you forget how to say substitution. Okay, and now we have one angle down. We only have one to go. This should be automatic. All right, when you see these bow tie relationships, you should always be looking for, whoops, I didn't mean to save that. You should always be looking for your vertical angles. All right, so watch my board freeze now. But you can write that in on step 4. You can say angle 3 is congruent to angle 4 because vertical angles are congruent. And that's my second pair. All right, that's all there is to it. The only trick for this one is, this looks a lot like the first one we did where it told you these lines were parallel. But it doesn't say that in this proof. Okay, you can only use the information that they give you. So looking here, we have our vertical angles, we have our angle-angle similarity, and we're done. So we'll practice a bunch of these in class next time. Hopefully that video went well for you. Let me know if you have any questions, and I will talk to you guys next time. Bye.